Good evening, everyone, and welcome to tonight's webinar, which is being hosted by DD Group and our partner, BOFA International. I'm Fazila Rupani, I'm Head of Clinical here at DD, and I'm delighted to be co-hosting this session with our colleagues from BOFA. There's been so much discussion around how to mitigate the risk of transmission of virus particles over the past few months as we battle our way through this pandemic. And many of us are constantly trying to find out more about the different methods as we get back to practicing life. So this is a new area for us as dental professionals, but it's highly relevant given the kinds of procedures that we carry out with regards to AGEPs especially. And that's why DD thought it would be a relevant webinar to host this evening. So tonight we'll be discussing the benefits of extraoral aerosol extraction in the dental surgery. The webinar will be led by two experts from BOFA, Josh Evans and Luke Jakowski. Their presentation will last around 40 to 45 minutes, and this will be followed by a live question and answer session. So please feel free to type your questions into the question and answer box during the presentation, and I'll collate the questions into relevant themes, and we can discuss these at the end. We'll try to get through as many of the questions as possible. However, if we run out of time, we will collate the answers and put a link on our website where you can access the answers. So without further ado, I'd like to hand over to Josh and Luke from BOFA.
Thank you, Farzila. Good evening, everybody. So as Farzila mentioned, we will be covering direct aerosol extraction tonight and how to effectively reduce the risk of pathogen transmission in your surgery. And as Farzila mentioned, we will answer the questions that you may have at the end. So I wanted to introduce us first. My name is Luke Jakowski. I have about 15 years of experience in dental equipment, sales, and product development. As BOFA's Global Business Development Manager for the dental industry, I am passionate about developing solutions tailored specifically to the dental market. I've worked extensively with government agencies and dental associations around the world to bring solutions fit for purpose, and I champion safety awareness for dental clinic and laboratory personnel. My colleague, Josh Evans, he joined BOFA in 2017 as an applications engineer, having gained a first-class master's in chemical engineering from the University of Nottingham. He's accredited by the Institute of Chemical Engineers and has a solid foundation in fluid dynamics, particle mechanics, and absorption chemistry, meaning he fully comprehends the key components of any good extraction system. One of Josh's key responsibilities is providing pre-sales technical advice to sales engineers and customers to determine which BOFA system is the best for the specific application. He also develops and delivers training programs both internally and to BOFA employees and externally through the BOFA Academy. So why are we here? I think the most important reason we're all here is that you as dental clinicians have a need to get back to work. Get back to work with a focus on yours and your team's safety in mind. So reducing or possibly eliminating fallow time is a key issue for you. We need to reduce the risk created by AGPs to a minimum. To do that, one needs to understand how exactly this works. What are the different extraction types? What are the benefits of direct extraction? We will cover all of these topics today and introduce a solution that will give you the peace of mind needed to get you back to work and get patients back into your surgery. So a little bit about BOFA so you know who we are. BOFA specializes in capturing hazards at the source, filtering them, and returning the air safely back to you. BOFA started as a family-owned company 33 years ago. If you fast forward to 2020, you'll find that we are a global company, but still based in Poole. All of our products are produced in the UK, and we are the #1 choice for extraction in the world with 25,000 plus units deployed per year. We have won the Queen's Award for Innovation, and we partner with the British Lung Foundation to bring a breath of fresh air to your workplace. At BOFA, our expertise is workplace air filtration. We design fume extractors based on specific applications and specific needs. BOFA's technology is based on scientific research on aerosols and filtration. Our team of engineers analyzed countless research publications and white papers, then combined the data with industry requirements and feedback to bring the best filtration possible to your surgery. We use high quality industrial heavy duty components because we understand the dental surgery and its environment. The global dental industry has highlighted a significant concern over the transmission of SARS-CoV-2 and the aerosols created during the examination and treatment process. Although the scientific knowledge around SARS-CoV-2 and COVID-19 is limited, the knowledge around aerosols, their capture, control, and filtration is well understood. Dental practitioners are at a higher risk of exposure to pathogens that may be carried through aerosols due to the close proximity of the patient's oral and nasal areas, which are seen as the prime transmission point. And the use of PPE does not provide sufficient protection to its wearer, and it is recommended that the risk from aerosol could be further reduced by diverting, capturing, and containing the aerosol within a suitable extraction and filtration device, where it can become no longer viable and then disposed of in a safe manner. Appropriate PPE for practitioners mitigates some of the risk of transmission, but more can be done to stop aerosol reaching the breathing zone of the practitioner and the clinical team. To understand the different forms of control and protection, I would like to introduce you to Josh, our applications engineer, and he'll be able to explain this further. So Josh, the stage is yours.
Thank you very much, Luke. So the first thing I want to do is run through the different forms of control that are available to dental practitioners. While I'm doing this, I'd like everyone to keep the picture of a dental surgery in their mind, where you have your patient, which we'll assume to be the source of COVID-19, one or two dental staff working on them. Then you may have a direct extraction unit, like shown in green on the slide here, or you may have general ventilation, air purifier in the top right-hand corner there. So as we're going through all of these, just keep that in your mind's eye, and we should move forward. Before we look at anything specific, I wanted to talk about the hierarchy of control. Many of you may be aware of this, but for those that aren't, this is used internationally across many industries to control hazards. The higher up on the hierarchy of control you are, the better the control method. And it doesn't matter what the hazard is, whether it's a virus, a toxic substance, falling from height, or even stress at work, you can apply this to the hazard. So if we look at this, the first step is elimination. Can you remove the hazard? And that's what we've been doing in lockdown. You've been removing patients and dental staff from the surgery, and therefore the hazard does not exist in the surgery. However, this isn't sustainable long term. So then we move on to the next stage of the hierarchy, which is substitution. Not so applicable to our situation, as it would involve swapping out the COVID virus for a different virus. So yeah, not exactly practical. Then we move on to engineering control. And this is where extraction systems like BOFA sit and other engineering methods. Below that is administrative controls. And what this would be is the type of things you've seen pop up, which is one-way systems, encouraging people to wash their hands more often or not shake hands at all. So administrative controls are to do with changing the way people work. And then right at the bottom, we have personal protective equipment. And this would be things like gloves, face masks, eye protection. And it's something that many people don't understand, that PPE should actually be your last line of defense, whilst many are treating it as their first. And the analogy that I've been using is when you're driving your car, your seatbelt is your personal protective equipment. Now, you rely on your engineering controls, like your brakes and your indicators, and your administrative controls, like the rules of the road and speed limits. But you don't just crash into things and rely on your PPE, which is your seatbelt, to save you. So like PPE, you should always wear your seatbelt, but you should never have to rely on it. So why is PPE so far down on the hierarchy? Firstly, it only protects one person. In our car example, your seatbelt protects you, but it doesn't protect other people in the car, people in other cars, or people on the pavement. So it only ever protects one person. Second of all, it holds the contaminants right next to your breathing zone. So if it fails completely. And also handling of the PPE is a hazard in itself. PPE such as face masks and eye protection needs to be face fitting. Many people have been using surgical masks, which are great for preventing splatter and stuff like that, but aren't suitable for preventing aerosols, as there is gaps around the side. The Centre of Disease Control said that surgical masks protect the mucous membranes of the mouth and the nose from droplet spatter, but they do not provide complete protection against inhalation of airborne infectious agents. During aerosol generating procedures conducted on patients assumed to be non-contagious, dental staff should use an N95, equivalent to FFP2, respirator, or a respirator that offers a higher level of protection. And this is because surgical masks aren't designed necessarily to protect you from aerosol contagions. Then their primary role in surgeries is to prevent the surgeon from coughing or sneezing into open wounds that they're operated on patient. Again, this doesn't mean that PPE shouldn't be used. It should definitely be used, but it has limitations that other forms of control can plug the hole of. So first of all, I'm going to group together general ventilation, room scrubbers, and air purifiers. And the reason I'm going to group them together is because they all come under the same category of dilution ventilation. This is where you introduce a supply of clean air with the goal of diluting it down below safe levels. If you look on the right-hand side, this is research that the Centre of Disease Control has conducted. And it's to do with how, if you have a dilution ventilation system that has a certain number of air changes per minute, then how far you can reduce contaminants down. So by example, if we look at the second row, if you have 4 air changes per minute, after 35 minutes, you can remove 90% of contaminants from the room. After 69 minutes, you can remove 99% of contaminants from the room. And after 104 minutes, you can remove 99.9% of contaminants from the room. Many people think that after 1 air change, the air is completely clean. And this isn't true, because dental practices aren't designed to be aerodynamic. They have airflow dead spots, they have back eddies that can cause incomplete dilution. Where they're really good is between patients. So when one procedure finishes and the next procedure starts, bringing any leftover contaminants down to as low a level as possible. And that's related to fallow time. Where they have drawbacks is that they don't tend to generate a high enough airspeed in the room to capture all of the aerosol. So the smallest aerosol droplets could diffuse away from the air purifier faster than the airspeed is towards them. And also the droplets that they do capture can come into contact with any surfaces, equipment, or people that are on their path. As I said, it's a really good method when you're talking about the time between patients. So not preventing transmission from one patient to the dental staff, but rather to prevent transmission from one patient to the next patient. People have been asking us questions about this type of system in relation to fallow time. And it's maybe not as straightforward as people think. Fallow time is designed to allow the droplets and the aerosol to drop out between patients and to settle so that they're no longer airborne. But by introducing an air source, you're actually increasing turbulence in the room and therefore keeping particles and droplets in suspension for longer. Although you're probably actually doing a better job of removing the contaminants from the room. So we'll look at HSG, Health and Safety Guidelines 202, which is the Health and Safety Executive's approved code of practice for general ventilation. They say, if contaminants is of such a low toxicity and produces such a low concentration that it would be impractical and uncostly to use local exhaust ventilation. Local exhaust ventilation is what BOFA handles. You may decide to use general ventilation as part of your control strategy. When you use general ventilation to control exposure to contaminants generated from industrial processes, it is essential that the rate of contamination produced is low enough to be effectively diluted by the airflow rate. The contaminant has a low toxicity. The contaminant is produced at a uniform rate. The workers are positioned at 90 degrees to the airflow rate. And the contaminant is generated in low concentrations and can be controlled to the assigned occupational exposure limit. Now, there is no occupational exposure limit for SARS-CoV-2, but in this context, I would consider it to be a high toxicity. So using these general ventilations as a control method, as we've seen some people try to do, isn't going to be that effective. Then if we look at HSG 258, which is the approved code of practice for local exhaust ventilation, again, that's what BOFA handles. Dilution or mixing ventilation. Clean air dilutes contaminants workplace air by mixing with it. The assumption that the concentration of contaminants is uniform throughout the workplace is common, but usually wrong. In practice, mixing is incomplete because there will be some areas of high concentration in the workplace, usually near the source. What that means is that when you're conducting your aerosol generating procedures, the concentration is going to be highest by the patient's oral cavity and then decrease the further you get away. So by putting a general ventilation system or room scrubber at the edge of the room, you'll only be treating the lowest concentrations of the aerosol. And the Centre of Disease Control said, consider the use of portable HEPA air filtration unit, like BOFA's, while the patient is undergoing and immediately following an aerosol generating procedure, rather than just relying on built-in HVAC system capacity. And that's on guidelines that they've given to American dentists in relation to COVID-19. Other forms of extraction are going to be your intraoral extraction. These are really good as they're next to the, well, they're as close as you can get to the aerosol generating procedure as possible, but they do have drawbacks. They're designed to handle mostly liquid, which means that they have a very high pressure, but a very low volume extraction rate. This is really good for liquids, but not so good for aerosols in air. For that, you need high airflow, and pressure isn't as important because the pressure dissipates quite quickly through air. So next we'll look at direct extraction, also known as local exhaust ventilation, and this is what BOFA handles. It involves capturing the hazard, regardless of what it is, whether it be a virus, a contaminant, or an allergen, capture it at the source, and then we pass it through a series of filters and return the air back to the room cleaner than normal room air. It has many advantages. First of all, you're preventing the spread. So you're stopping it from getting onto surfaces and even onto other people. We use high-grade HEPA filters, which are suitable for filtering 99.997% of particles. If you compare that to your FFP2 mask, which remove 94%, so several orders of magnitude higher. And also then your virus is held inside the filter system, where it's very difficult to accidentally come into contact with it, as opposed to a piece of PPE, where it's held right next to your breathing zone. The other advantage is that it can also act as a room scrubber or dilution ventilation at the same time. So it's in a dental surgery of around 50 meters cubed. The BOFA DentalPRO Aerosol will achieve 4 changes per hour, which means that after 69 minutes, you'll have achieved a 99% reduction in contaminants. And that's ignoring anything you've captured at the source. That's just anything that was in the room to start with. 99% of that we'd expect to be removed. So if you're capturing the virus at the source, or the virus contained in an aerosol at the source, you could make the argument that you could significantly reduce or even remove fallow time between patients. So we've been through a few different examples, and one analogy that I've been using, even if it's a little silly, to kind of explain this stuff is my leaky pipe analogy. So instead of a patient infected with COVID, imagine you've got a leaky pipe. Direct extraction, like BOFA's, is like putting a bucket under that leaky pipe. So capturing it at source and keeping it there. Whilst general dilution ventilation or air purifiers is like putting a drain in the corner. It will eventually capture it, but you have to wait for the whole room to flood before it does. And then wearing PPE is like wearing wellies. You're protecting yourself from the hazard, but it's still there. So one question we get asking a lot is, what can I leave out? Essentially, what don't I have to spend money on? Unfortunately, I can't answer that question for you, but I can say that as many layers of control that you can add to this process, the better, because that will protect your staff and protect patients. So now we've looked at a few different forms of control. I wanted to run through the primary principles of extraction that we apply to a wide range of industries, but specifically to the dental industry. Step one is always going to be identify the hazard. So we're going to assume that it's the patient that is infected, as they're the one who will be transferring stuff during an aerosol generating procedure. But also, it's not just aerosol generating procedures, but breathing can, there's some research to suggest that this can also generate aerosols. During the aerosol generating procedure, the largest droplets will initially be thrown furthest, but as they're more bound by gravity, they'll fall out, and then it's the smallest droplets that will be able to remain in suspension. And unlike other hazards, the droplets can actually evaporate and become smaller, making them more likely to travel further. And they may even evaporate to the point where the virus itself is exposed, which is getting down to 120 to 160 nanometers. Sorry. Okay. So the next step is capture. And it doesn't matter if you have the best filters in the world. If you're not capturing the hazard, it doesn't matter. So we use many tools. We can use computational fluid dynamics, but one of the primary tools is something known as Fletcher's equations. These are equations that have been developed over long periods of empirical testing, and they allow you to calculate capture distance and airflow rates in extraction systems. If we look at the equations, they're on the right-hand side. X is the distance from the nozzle, from your capture device. So the smaller you can make that, the better, because you're going to increase your capture rate significantly. A is the cross-sectional area of your capture device, and W over L is the width to length ratio. So this is why you see a lot of circular nozzles in this type of industry, because a width to length ratio of 1:1, which a circle has, is one of the most useful. Then you plug all of this information into the equations, and it gives you the relationship between your capture velocity, which is the velocity required to capture different types of particulate, or aerosol in this case, over your hood velocity, which is the velocity at the nozzle tip, which you can then calculate into an air volume. And all of this allows us to refine the information that we're getting back from the field, and select an extractor with a very specific airflow rate, very specific nozzle size and shape. And what you get is a diagram similar to what you're seeing in the bottom right-hand corner. So what it shows you is that at the face, you have 100% of your capture velocity. But after half a diameter from that nozzle, you get around 30%, and at 100% of the nozzle distance, so if you had a 100mm nozzle, at 100 millimeters from the nozzle, you'd have around 7.5%. So you can see how quickly the airflow rate dissipates the further you get. And that's why we see these room scrubbers being sold as preventative measures for direct transmission between patients and clinical staff. But that distance really dissipates their airspeed. So it's better to be as close as possible with your direct extraction system. And something that ties very tightly into capture is the importance of the airflow, so the fluid dynamics that you're generating. It sounds simple, but one of the most important things is to ensure that you're directing air away from your clinical staff. You don't want to put this nozzle by your head up here, you want it on the opposite side. It's obvious, but it's a consideration where the position of your extractor nozzle may need to change depending on if you're working 2- or 4-handed. You also want to encourage a clean airflow. Air doesn't like changing directions, so you want a clear path for the air to travel from the target area to your capture nozzle, and you want to prevent any kind of dead spaces or back eddies. So something as simple as being wary of where your hands will be positioned throughout the procedure, and positioning the nozzle accordingly. Next, we'll look at the filtration. So the DentalPRO Aerosol works off a 3-stage filtration system. The first stage is what we call a pre-filter. And what this is it's a low-grade filter that gets rid of any dust, any larger particulates that may be generated by other procedures, and protect the HEPA filter, which is the one behind it. And we'll talk a bit more about the HEPA filter, but this is the high-grade filter that is going to be filtering the virus. So the pre-filter protects the HEPA filter to extend its life. And then the final stage of filtration is our activated carbon filter. This is a high surface area chemical filter, and it's designed to remove any volatile organic compounds or odors that may be generated by procedures or even just are in the background room. So bringing the comfort level of the room back down. But we'll make sure that we understand how HEPA filters work, as this is the really important section. And this is the one that's going to be removing the viruses. HEPA filter stands for high efficiency particulate in air. BOFA HEPA filters, as I've said, are rated to remove 99.997% of 0.3 micron particles. For those that aren't aware, 1 micron is 1,000th of a millimeter or a millionth of a meter. The next 1,000 down takes you into nanometers. So what we've got here are some of my reasonably crudely drawn diagrams. On the right-hand side, you can see a demonstration of the filter. So the green circles represent filter fibers. The blue lines represent the airflow through the filter. The black dots are particles or viruses in this case. And then the colored dotted lines are representations of the flow paths. Then if we go over to the left-hand side of the screen, that is a graph representative of what we'd see from filter efficiency. I've exaggerated this quite a bit just to make it more visible. It's quite difficult to show 0.003% dip in a graph, so I've exaggerated the features here. But the reason why it's worth explaining is because many people believe that filters work like a sieve. So you have holes in your filter, and if the particle's too big to get through, then it won't. But this isn't true. It's when you get down to this scale, the filter has real depth, and it's more like trying to move through a hedge. So if we look at the diagram on the right-hand side, at the bottom, you've got the sieving effect. So this is where particles are too big to get through. But as you can see from the graph on the left-hand side, the blue line, this decreases quite rapidly as this effect decreases as particle size decreases. Sorry, I should have explained the graph on the left-hand side. On the x-axis, you have the particle size in microns, and then the filter efficiency as a percentage on the y-axis. So if you look at the blue line going from right to left, the sieving line decreases pretty readily. The next effect is inertial impact. So the particle tries to move forward, but it simply comes into the path of one of these filter fibers. Again, that's good at filtering particles finer than the sieving effect, but it drops off as particle size decreases. Next effect in purple is the interception, which is where the air moves around the filter fiber and the particle tries to move with it, but because it's not as free moving, then it gets caught by the filter fiber. The final effect is the most important, and this is the diffusion effect. What this is it's also known as Brownian motion, but as you're sitting in your chair or wherever you may be, the air is bashing into you constantly. And you don't feel this because relative to the air molecules, you're very large. But as the particle size decreases and decreases and decreases, and we're getting down to the size of our coronavirus at 0.14 to 16 microns, the air has a real effect, and it causes the particle or the virus to move in a really erratic motion. And the smaller it is, the more erratic it is. And the more erratically it moves, the more chance it has to come into contact with a filter fiber and be filtered. What this means is that for this diffusion effect, the smaller a particle size is, the greater the effect of this filtering mechanism. So when we quote 99.997% at 0.3 microns, 0.3 microns is the established most penetrating particle size, which means that particles larger and particles smaller, which would include our coronavirus, have a greater efficiency than 99.997%. I'll pass it back to Luke now.
Thank you, Josh. That was very fascinating. I think we have a much better understanding how extraction and filtration works. So let's take a look at the tool that we can use to achieve our goal. So this is the DentalPRO Aerosol extractor. So the DentalPRO Aerosol has been developed to help reduce the risk of pathogens transmitted via aerosol during dental examinations and treatments. When positioned, it will capture the aerosols and other contaminants emitted by the patient and divert it towards the DentalPRO Aerosol, diverting it towards the DentalPRO Aerosol, where it can be controlled, contained, and filtered before being returned back to the working environment. So with proven market-leading airflow to ensure optimum capture, it is designed to work alongside appropriate PPE and distancing guidelines. It is simple to use and maintain, and there's no need to vent outside as the filtered clean air is returned back into the room. So the DentalPRO Aerosol was designed to fit your clinical process, but at the same time, give you the maximum extraction efficiency needed to remove and filter the aerosol generated during treatment. And here you have some pictures to show how the unit looks in a surgery next to a chair. The DentalPRO Aerosol is manufactured from high quality materials and components, giving you, the customer, peace of mind that the equipment you purchase will have a long service life. The filter exchange process is very easy, and the filter life allows for annual changes. Inside, you'll find a 3-stage high-efficiency filter, as Josh mentioned, made up of a pre-filter, a HEPA filter, and the activated carbon gas filter. These 3 stages of filtration ensure that all you get in return is a breath of fresh air. The ergonomic 4-piece arm allows for quick and accurate positioning. Together with an adjustable flow rate, you can achieve the high capture velocity needed to extract the aerosol into the filters. All the surfaces can be wiped down and are easy to clean, and the extractor is fully mobile with multi-directional lockable casters. Finally, an easy-to-read set of indicators can inform you about the flow speed or if the filter is full. The proven efficiency of the HEPA filter with a minimum filtration level of 99.997% is sufficient to capture contaminated aerosols. We provide an effective airflow, which along with the correct capture position and correct filtration principles will allow to achieve the best possible results. The BOFA DentalPRO Aerosol is designed to add an additional layer of protection from harmful pathogens found in aerosols generated during treatment. The unit is also designed to be easy to deploy, requiring no technical installation support. The filters are changed annually utilizing a service box that is available. However, should an earlier filter change be required, it can be achieved by your clinical team with ease. BOFA and Dental Directory support all its partners via live chat, online technical help, telephone support, and training. We offer direct training, webinars such as this, supporting material, and if required, field visits. You will have access to specific BOFA Academy training programs that relate to extraction. One of the most important parts of a good product is the warranty. Because we use superior components based on demanding industry standards, and due to the extended service life of the extraction pump, we are able to offer an industry-leading warranty of 24 months. It is the peace of mind you should expect when choosing a solution for your surgery. So let's take a step back and talk about the elephant in the room. So we talked about why are we here. We talked about the details of risk management in the surgery. It is clear that the primary aim of the system is to protect lives, improve operatory efficiency, and mitigate further risks. Clearly, the case before us for protecting lives is undoubtable and should not be understated. You can't wipe down the air, but you can remove the aerosols from the equation with proper extraction. So, removing the aerosol means we can talk about the elephant, fallow time. It's on everybody's mind. How do we reduce it? Can we eliminate it completely? It is widely considered that many dental procedures create a negligible level of aerosol and should be considered a low risk. In these circumstances, the operating area can be decontaminated without implementation of a fallow period. However, where AGP is concerned, fallow time is recommended. However, if you remove the aerosol at the source and correctly filter it, you can reduce fallow time to a bare minimum. Some would even say completely. This can be achieved with the introduction of direct extraction such as the DentalPRO Aerosol. This is because the device removes airborne aerosols, reduces exposure to contaminants, allows for safe capture and disposal of aerosols, and finally it goes further. It continually cleans the room. So by introducing engineering controls into the dental clinic, you may be able to reduce the fallow time recommended between aerosol generating procedures. With a direct extraction solution, a full risk assessment can be completed by you, and fallow time can be reduced to 10 minutes or even less. The mitigating processes that help achieve this are the direct removal of the aerosol away from the patient, the control of the aerosol, diverting it away from the clinical team, and finally, providing a room air change up to 5 times per hour in a 20 square meter surgery. All of this allows you to increase the throughput in your surgery. More patients per hour, no restrictive barriers, no additional wipe downs, no further changes to your protocols. The DentalPRO Aerosol costs your practice £1.30 per hour in the first year. This cost goes down to 13 pence per hour in the second year. Meanwhile, both your patients and clinical team are more confident about their safety in the surgery, patient loyalty increases, and you are able to reduce your PPE cost. So we have learned that maximizing mitigation protocols is the best practice when dealing with pathogens. We have also learned that direct extraction is the most efficient way of removing aerosols that create the risk and force the dreaded fallow time. Dental Directory and BOFA have teamed up to offer a high quality and high performance solution that is easily integrated into your practice process. The vast DD support network will give you peace of mind, and the DentalPRO Aerosol will allow you to have a safer work environment. But most of all, our solution will help put more patients back into your surgery. So I'd like to thank you on behalf of Josh and myself for the valuable time you give us tonight. It's time to pass the microphone back to Farzila to begin the Q&A session. Thank you.
Thank you to Luke and Josh. That was a really great session, great presentation, and you raised some really interesting points. And I think a lot of the points which are on a lot of clinicians' minds at the moment, especially with regards to fallow time and how we can get back to working in the most efficient manner. So I'd hand over to our audience right now. We're happy to take any questions that you may have. I actually had a couple of questions sent in to me prior to the webinar, so I can start with those whilst we wait for everyone to raise their questions. So one of the questions raised was about cleaning. So in terms of how we clean, you know, the funnel or the pipe or the unit, is there a special way that this is done? Obviously, we are used to our usual suction units and the cleaning protocols and methods with those. I assume this would differ in some way, and how would that be?
Yeah, well, I'll take this one if that's all right, Lee. So, I mean, the virus itself, when captured by the DentalPRO Aerosol, will be contained inside the filter unit. So in terms of cleaning, treat it like any other surface. It's designed to be wiped down. And yeah, unless you have a 75mm hand that can reach 2 meters down the nozzle, you're going to be protected from the virus contained in the filter itself. So yeah, treat it like any other surface or any other piece of, in the dental practice.
Okay, and that's obviously the outside area of cleaning. What about internally? Is there some servicing that's required, or how does the internal cleaning work? I guess this would probably relate to how often you change the filter.
Yes. So so in terms of servicing, each one has an annual service, and we'd expect this to coincide with the filter change. So we'd actually expect the filter life to be longer than the annual service, but might as well do them at the same time. In terms of protection for this, I would advise it's good practice to treat any used filter as a contaminated surface. But say if you finished your procedures on a Friday afternoon and then came in Monday morning to do a filter change or a service, you'd expect a lot of the virus to be, well, not dead, but inactive over that 3-day period. But again, it's always good practice to treat a filter as a contaminant to be on the safer side.
Thank you. So we have another question, and someone has said, we use a HEPA filter. How long can our fallow period be? Would it be 60 minutes? I guess this is a bit of a debatable one because it kind of depends on what HEPA filter, what system they're using, but I'll let you guys answer and give your thoughts.
Yeah, so I mean, HEPA filters, so there's a few different grades, but the lowest one is 99.97%. So lower than ours. We use an H14 equivalent, if anyone's interested in filter classes. So in terms of the air coming out of the back of the unit, I would say a HEPA filter is removing almost all of the contaminant with that 0.003% maximum being left over. So then it comes into a case of, okay, are you capturing it, or are you relying on air changes per minute? I would say if your system is 100% effective at capturing the contaminants coming from the aerosol procedure, then there is an argument to be made that fallow time is no longer relevant, because you're waiting for aerosol to drop out of the room. But if it isn't there, then it's not so relevant. But if you're doing general scrubbing, then if you're doing a sufficient number of air changes, then you can reduce your fallow time significantly.
Thank you. So, I mean, I guess what wasn't specified in the question is the HEPA filter part of an air filtration unit? Exactly. Or is it part of, for example, an extraction unit? Because I assume the process would differ slightly, and how it would have an effect or an impact on the fallow period would also differ. To the person who asked that question, if you do want some more information on that, please feel free to email us some more detail, and we can help to answer that. Someone else has asked a really good question. At what distance should we keep the funnel from the patient's face? You know, as dentists and dental care professionals, we're always shoving lots of things in faces, and I think we're used to it, but sometimes they do get a little bit overwhelmed. So what kind of distance would you suggest?
So I would suggest the closer is better. We're predicting around 150 to 200 millimeters based on like how dentists work, and also the equations that I've mentioned in my section. We're actually working with Edinburgh University to have like practical validation of this, which we're getting. We don't have full results back yet, but their initial feedback has been very positive. And also working on things like computational modeling of aerosols, because anything less than 30 microns you can't see with the human eye. So developing like great test methods for that can be tricky. So we're working with our parent company Donaldson to come up with some computer simulations for that type of event.
Excellent, thank you, Josh. The next question is, will air conditioning affect the function of the extractor?
So it depends. In general, no. So normal air conditioning, I wouldn't say so. Things to consider would be things like desk fans or open windows nearby. Particularly desk fans, because blown air is really directional in compared to extracted air or drawn air, and that's why you blow your birthday candles out. You don't suck them out. It's because blown air is a lot more directional. So if our system were competing with a normal general ventilation system, it's not going to affect it measurably. But something like a desk fan, maybe be aware of that, and particularly in the summer, keep that directed away from your target area.
Great. Someone else has asked, can the dentist change the filter, and how is the filter disposed of? And the same colleague has asked, do DD come and change the filter? So I would say yes, DD engineers are going to be available to change the filter and offer this service on an annual basis. And probably I would leave it to the expertise of the engineers to deal with, especially because the filter could possibly be contaminated. You want to make sure you're handling it in the right way, would be my view. Josh, Luke, I don't know what your view is. I assume it's the same.
Yeah, I think I would agree with you that, you know, because all local exhaust ventilation in the UK must be serviced every 14 months, 12 to 14 months by law. It sort of falls in line with exchanging the filter. So you have to have it serviced, so let the engineers handle it. But as we mentioned in our presentation, if for some reason the filter ends up getting filled or full earlier than that, we will have a protocol in place for you to follow so you can safely remove and dispose of the filter. When it comes to the disposal of it, it's a bit of a tricky question because you don't quite know what has been captured in the aerosol other than the COVID. Because we know that after a certain amount of hours, the virus becomes non-viable. However, we don't know if you have been drilling into an amalgam and maybe some mercury got into the aerosol and got put into the filter. We're not quite sure what else you're going to put into the filter. So what we suggest is if you are going to be disposing of it yourself, to contact your local disposal service and just speak to them and see how they would treat it and act according to your local regulations.
Fine. Another question, I guess this is a little bit similar to whether air conditioning affects it or not. Someone has asked if a window is open at the same time as the unit, will this affect the strength? Will it give the same strength of capture?
So again, it's one of those questions which are, if like trying to understand the situation. A window open by itself, I wouldn't say so, considering that most dental practices, you know, the patient is centered towards the center of the room, windows open at the far end. The effect that can have is relatively minimal. But there may be things like, say someone opens the door and the window and the door are perfectly opposite each other and cause this coincidence of perfect air dynamics through the dental surgery, could possibly influence it. I wouldn't expect it to be significant.
Thank you. A good comment here. Someone has said, if the air intake funnel needs to be so close to the patient, would it not be better to make it out of transparent plastic so that the nurse can see the mouth better when aspirating? So using the intraoral suction, which actually is a really good point. And I know that the BOFA team are looking at design modifications, you know, and improving design. So I guess it's some feedback that you could look at and see whether it would be viable or not. Absolutely.
I mean, we've looked into this already, and it's something that we suggest on other applications, based on because putting a physical barrier between you and the hazard is good, but from the type of perspex and glass, well, you wouldn't want glass, but perspex style enclosures, the visibility is pretty significantly diminished. So your ability to work is affected. Having said that, that's something that we're continuously reevaluating. If we find some new plastic or material that's better suited, then absolutely, it's the arms that we have are designed to take multiple attachments. So it's something that we could definitely reevaluate.
Thank you, Josh.
I wanted to add a little bit to that. So if you follow our guidelines for placing of the funnel, you should be placing it in an area that is away from your work space, exactly. I can say. So if you're working forehands, you would put the nozzle somewhere in front of the patient, about 15-20 centimeters away from the mouth. If you're working yourself on the sides or however where you work, you can put it on the opposite side of yourself. So as long as you follow the guidelines that we set in the user manual, you should be pretty good about not infringing on your workspace. However, if you find yourself having some trouble with that, just reach out to either your DD support or to us, and we'll be happy to help you find the solution that will allow you to work. This system is supposed to help you get back to what we would call normal work as you did before. So it's not supposed to get in your way. So we do everything possible to allow that. If you have a specific situation that may be preventing it, just let us know and we'll find a way to solve it for you.
And Luke, actually, on that, you mentioned using it obviously with a patient and then away from a patient, you know, at a work surface. So I guess a really good example that I could think of would be like a lab technician, if a dental technician is working in a lab and using it. Also, for example, when we're trimming our dentures or making adjustments to crowns or something away from the patient but near a work surface, it would be great to use a unit like this to extract any of the particles that are coming out. You know, hopefully the denture, if it's come from the lab or the crown, is not going to be infected with anything, but still there are particles which are going to be generated when we do adjustments. So capturing those with this extraction unit would always be useful. I guess another design question, which is another interesting one, has been put into the webinar chat. And this colleague has said, have you considered having a ceiling mounted unit that works like this to avoid further boxes and equipment all around the floor? And, you know, as some of us know, some surgeries can be so tiny and cramped to work in. I definitely know that in some of the ones I've worked in the past. So I guess if we can avoid more equipment on the floor, is there a possibility, or what would you suggest for that?
So this is it's an approach. It has its limitations though. So our units are designed, you take it out of the box, you attach the arm and plug it in and it's ready to go, rather than having to have an engineer install a ceiling mounted system. Other thing I'd consider with that is, if it's ceiling mounted, your filters are ceiling mounted, which means that someone's going to have to conduct a filter change with a possibly contaminated system up a step ladder, which has its own realms of safety implications. So our systems are designed to be plug and play, and actually having it on the floor can solve issues that would be caused by a ceiling mounted unit.
Thank you. Someone else has said, how would an extraoral suction unit fitted with a funnel work in comparison to an extractor? So, you know, obviously we've got intraoral suction. Sometimes we also have the extraoral units, I think like the mobile units and things like that. If you fit that with a funnel versus using an extractor, what would be the difference? Yeah,
so I think here we need to understand that the DentalPRO Aerosol is a totality of different points, which is the filtration, the extraction, the airflow, the design of the arms, things like that. So just putting a funnel on another piece of extraction equipment will not reach the same goal unless it has the right airflow with the right pressure, with the right filters behind it. So I guess you could say that would sort of do the job, but in effect, if you don't have all three of those things combined, you will not do the same job.
Right. Someone else has commented that what makes this unit more efficient than the other competitors who also say they have HEPA filters capturing at 0.3 microns?
So it depends on the filter type that they're using. There are a number of different HEPA filters. There's HEPA, let me get this right. I think it's 12, 13, 14, and 15. Oh no, 15 you get into the ultra grade filters. So we're on the third rung on the ladder up. But if someone had a comparable filter set, then it would be the same filter. The difference would be whether they've designed their capture system as efficiently as us.
Okay.
So if I could add to that, and I don't like to belabor the point, but one of the reasons why we believe our proposal is superior is the fact that we have over 33 years of experience of dealing with extracting of fume and dangerous gases. And we are able to combine all of that knowledge to give you a very confident proposal that this will work. I can't comment on I'm not sure which competitor we're talking about here, but in general, we have found that our competitors in the market are companies who come from the dental field, maybe they come from just an air filtration field, like as you know, room filtration, but they don't have experience in actual local exhaust ventilation, which is what needs to happen in this situation. So I would say that you cannot compare two machines by looking at the efficiency of the filter. You must look at, as I mentioned before, the filter, the airflow, the noise, the pressure in the system, things like that. And if you put all that together, then you can really compare apples to apples. If you do it one by one, it doesn't really give the whole picture.
So Luke, on that, you mentioned noise. How noisy is this system?
So it's funny you asked, because we just did tests today to do some more elaborate tests to give you some fresh results. And we have found that the unit at full speed, so again, consider what you see in a data sheet. Most likely in a data sheet from any manufacturer, you will see the decibel level at a comfortable speed that makes it not so loud. What we've done is we've set the machine at the full extraction speed necessary to achieve the goal of removing the aerosol. And at that full extraction speed of 200 cubic meters per hour, we're getting below 70 decibels. So between 65 and 70. There's a bit of an error in measurement that can happen. So we measured some at 65, some at 68. So let's just say below 70, and we'll be fair.
Excellent. Thank you. Right. Well, I think, we've had lots of questions. I think most of them have been answered. There's a few unanswered, but as I said, we will post some answers on our website as we are short of time. We're already past 8 o'clock. And I think some questions that were asked quite a bit on the chat were about the cost of the unit and also the price of filter changing and engineering services. So there is actually an evaluation form that will be sent out to all of you in the next 24 hours. And on this evaluation form, it will give you details of a special offer that we are running at the moment following this webinar, which will give you details of the offer to purchase the BOFA unit, as well as finance options. And if you are interested, then someone from DD can call you back. You can just put your details on the form and one of the sales team specialists will call you back to discuss your requirements with you. So we'd appreciate you filling in the form. You can give us feedback. We always love to hear what you think of the sessions. And in addition, it will enable you to get your CPD certificate sent to you. And if you have any further questions, following today's session, please email them into us as well, because we're happy to answer them. Or if you speak to one of our sales team, they'd be happy to answer them as well. So I'd like to close by thanking Luke and Josh for delivering a really great webinar, really informative session, and a great question and answer session as well. I think you provided us with some great information that we can go away and think about to help us get through these tough times. And thank you to our audience as well for listening, and we look forward to hosting you again in the future. We've got some more webinars planned in August, and we'll be featuring some new products that will help you during these tough times, and hopefully we'll see you again. So thank you and good evening.